Today we're going to focus on the Earth's atmosphere. As you can see in the upper right picture, there are the levels of the atmosphere. We're going to focus on 5 main levels from the ground to space. The first one includes the troposphere. This is where we live. This is where weather will occur. This is where a majority of the clouds will be. Above the troposphere, we will have the stratosphere. The stratosphere contains the ozone layer, which prevents UV light from penetrating. The stratosphere will also be where the jet stream is. This is where planes fly. Then we have the mesosphere, M for mesosphere, M for middle. This is also where the meteoroids or meteorites burn up. The fourth one is the thermosphere. This is going to contain majority of the polar lights, the different auroras. Radio waves will also be transmitted here. And lastly, we have the exosphere. This is where satellites will orbit the Earth. This is also going to be considered the hottest layer, as well as this is the layer that touches space. Now, in some resources or textbooks, the thermosphere and exosphere are divided into the thermosphere, ionosphere, and then exosphere. So basically, why is the atmosphere divided up into 5 different parts? It's going to be identified by pressure changes, but most importantly, temperature changes. So as we go higher up into the atmosphere, it is not just going to get colder, it's going to change. It may get colder as you go higher in the troposphere, but as we move to the stratosphere, it's going to get hotter. Then when we go to the mesosphere, it's going to get colder again. Then as it moves past the mesosphere, as it moves into the thermosphere, ionosphere, exosphere, it's going to get hotter, hotter, hotter. Air pressure is measured by a barometer. So air pressure is also known as barometric pressure or atmospheric pressure. This is going to be dealing with the pressure that's exerted or given off by the weight of the air in the atmosphere of the Earth. The higher you go, the pressure will decrease. The deeper or lower you go, the more pressure. So if you think of a submarine, the deeper it goes, that submarine can be crushed, more pressure. The higher you go, less pressure and the air molecules spread apart. That's why when you go up higher in a mountain, it's harder to breathe, less air molecules. Not really that there's less air molecules, but these air molecules are further apart, not as close together. As I just said before, the air temperature as it rises in the atmosphere does not just get colder, colder, colder. As it moves into the troposphere, it does decrease, but the temperature then increases in the stratosphere, decreases in the mesosphere, and then increases in the thermosphere. Now, when it does pass the exosphere and reaches space, we can't really measure temperature in space because the gases are so far apart. Okay, really, we can't identify if it's cold or hot because there's not an accurate measurement of that. Now, in the troposphere, we have majority of your clouds, amassing in the troposphere. Also in the troposphere, we have a lot of convection. Cool air will sink while warm air will rise. Now at night, we know that warm air will rise, making the air cooler, making the temperature colder. But if we have clouds, especially stratus clouds, that will prevent a lot of the warm air from escaping, and it will keep it warmer at night. Now we have 3 modes of transfer of heat. The first one is conduction, which is direct contact. You're touching something hot, like you're touching the stove. Then you have convection, which is a circulation or moving of air or heat. And then we have radiation. This is transferred by electromagnetic waves. So radiation, this is like getting a sunburn, having UV rays from the sun hitting you. Okay, you're not directly touching the sun, but these waves, these UV rays are hitting you. That's radiation. Now in the stratosphere, we said that there's the ozone layer. Well, what is the ozone layer? The ozone layer is a gaseous layer in the upper atmosphere that protects us from UV, also known as ultraviolet light. This radiation can be very harmful. Another term in which ties into the stratosphere is smog. Smog is a pollution, and specifically it's a chemical pollution. Basically, pollutants interacts with sunlight and basically restricts visibility, makes it hard to see, makes it look all cloudy, and it is very dangerous to our health because if we're breathing it in, these are chemicals. So it's not just dust or smoke. This is actually a chemical pollutant. Now, we said the ozone layer is important. Well, let's talk about the ozone layer. The ozone is actually a compound. It's actually three oxygens bonded together. This is called O3. So O3, or the ozone layer, will be used, God designed it, to break apart the UV rays. Now, when we move into the mesosphere burns up the little meteors or meteorites or meteoroids, and it is the middle layer. Now, in the thermosphere, we have the different auroras. Basically, this glow at night is caused by different ions in the upper atmosphere. These ionized particles interact with the Earth's magnetic field, providing different colors. And then lastly, we have the exosphere. This is where the satellites orbit the Earth. Okay, and the air is extremely thin. This is right next to space. Now let's move into clouds. This ties in primarily with the troposphere. Clouds, what are they? They are droplets of water. Remember, a cloud is not gas, it is water. So gas water rises in the upper atmosphere, it condenses, turns back to liquid, and then these little droplets of water sit on different condensation nuclei such as dust, ash, or smoke. Now, the presence of clouds do help meteorologists know what weather is coming. We're able to predict the weather by looking at the different types of clouds. Now, 5 cloud characteristics you need to know is altitude, okay, how high they are, color, density, shape, and degree of cover. Fog. Fog is a cloud that is in contact with the ground. It's very low. If you ever walk through it, you walk through the condensation, these water droplets. So fog is a type of cloud. Now cloud names generally come from altitude and shape. Okay, altitude and shape. So we're going to first talk about the 3 main cloud types, which is stratus, which is a layer. Then there's cumulus, which is fluffy, okay, cotton ball shaped. And then there is cirrus, which is feathery. This is more of a shape. So here's the cumulus, fluffy clouds, the stratus, the layered clouds, and then the cirrus, the feathery clouds. But not only shape, we're going to tie in some of these terms, these cloud names, with altitude, cloud height. So the high clouds are also named cirrus clouds. So many times these cirrus clouds are going to be feathery, but they're also going to be the highest. Then we have a prefix or a term alto, alto meaning middle. If you ever heard of bass and soprano, alto is kind of in the middle. And then we have low clouds called stratus. So again, we have stratus meaning low and layered. Now there's another term, nimbus. Nimbus means a rain cloud. It's about to be rainy, so it gets very dark, and there we have color. Okay, so dark clouds generally are a sign that it's going to rain soon. The word stratus comes from the Latin to spread out, and these stratus clouds are low, thin clouds, and they're usually like a blanket or a covering. And these are formed when air is forced up slowly. That's a key. Please make sure you're aware of that. Stratus clouds are formed when air is forced up slowly. Then we have nimbostratus clouds. We're going to combine nimbus and stratus. This is a layered lower cloud that is filled with lots of condensation, lots of water, so it looks like it's going to rain or snow very soon. So this is a rain cloud. Then we move to the cumulus, the fluffy, the cotton ball, the heap, the pile clouds. So it comes from the word Latin for heap or pile. These cumulus clouds usually have a flat base. Many times they're billowing and sometimes they can be actually a large storm cloud and these clouds, these cumulus clouds, actually are formed when air is forced up rapidly, very high, very fast. The cumulonimbus, which we just said is the thunderhead, these are the dark, towering clouds. Then lastly, we have the cirrus clouds. These are the thin, feathery clouds, these little curls, but these are also the highest clouds. These are usually formed by ice crystals, giving it its feathery formation. And usually when there's fair weather, good weather, you can see these clouds, and they many times point in the direction of air movement. Now, even though they're a sign that there is fair weather occurring, many times they are seen before a storm happens. Now, we also have man-made clouds, which can be formed from jets and different airplanes. Basically, this is called a contrail. The condensation behind the jet is called a contrail. So if we combine some of these different terms, we have a stratus cloud, and it's kind of in the middle. We can call that an alto stratus. Or you have your cumulus clouds that are in the middle. We can call that an alto cumulus. We can have cirrocumulus. We can have stratocumulus.